Good morning, children. In the last class, lesson number 13, motion and time that I started. Today, the continuation part of that lesson, I will do it now. Okay, so last class, we spoke about what is motion, what are the types of motion, and how the body is under motion means how it is moving faster or slower, how to identify. That all we spoke to you. Okay. So what is motion means? What is motion? Do you remember, children? See, there is a gap between one class to another class. So 2 3 days gap will be there. In that gap, maybe you are forgetting. So before you could sit for the class, okay, once you read whatever the points I wrote on the board, whatever you underline, and what points is given in the box, that all you read once and sit for the class, so that there will be a continuation. That explanation part you can understand. Okay, so first, what is motion? That is not given in your text. So any moving body, that instance, that is we call it as a motion. So one body is under movement is called motion. Okay, types means we studied about the linear or straight motion and circular or periodic motion. Like that we studied. I told you about some examples also. Okay, like the movement of the car maybe, movement of the athlete maybe. Okay, so movement of the swing maybe. That all we identified with example which type of motion you recognized. Is it no? You written in the chart. Table 13.1, you written there. Okay, then we move to the faster and slower objects. So related to that, I spoke to you, if it is moving faster, a body is moving faster means how to identify. So we have to understand about the two things. That is, one is the distance. If distance is fixed, suppose a race is going on for 100 centimeter, the distance is fixed there. So how do you identify who is moving faster and who is slower means you can understand. So of course, who is covering the distance, who is reaching to the target with a shorter duration of time, he is considered as the fastest. So even the vehicle also, which vehicle is moving from one distance to another distance in shorter duration of time, we will consider that vehicle as a fastest vehicle. Okay. So in that way, who is faster and who is slower, we'll find out. So who is taking more time to cover the same distance, we'll consider it as the slower vehicle or slower body. Understand? So that is we learned in the last class. So today we will discuss about the topic speed. Okay, maybe you are familiar now already, you understood by the given examples there. Okay, so speed, how do we calculate the speed? Who is having the more speed? Who is having the less speed? Which body is moving in with a slower way it is moving or with a fastest way it is moving? How to identify means we will see the distance. Distance covered. And for that distance to cover, how much time it has taken. This is what we consider as a speed of the vehicle. Both we have to measure. See, this measuring you have to concentrate here. See, why we want to measure the time? Because by seeing the time only, the distance, how much it has covered and with what time it has covered, then only we can decide whether it is moving faster or slower. That's why this measurement is very much needed here. Time measurement is very much needed. Understand? So, here, most convenient way is to find out which two of the objects are moving faster or slower. It is known by the unit time. See, we have to find out the unit time. So, time we have to calculate. So, then you will come to know who is moving faster and who is moving slower. Okay. So, thus, if the distance covered by 2 buses in 1 hour, we'll call the distance covered by object in a unit time as speed. Okay, so the object is moving in unit time means in 1 hour. 1 hour is the time. How much it has taken? 1 hour. The bus has taken 1 hour to cover the distance. That is the unit time we have chosen. 1 hour for how much distance it has covered. So 300 kilometers, 350 kilometers, like that. Is it not? So that kilometers is the distance. Like that, the timings for also some units you have to measure it. So you have to measure the unit and measure the distance. Then you can find out the speed of that particular object or the vehicle maybe. Okay. So when we say that a car is moving with a speed of 50 kilometers per hour. See, a car is moving with the speed of 50 kilometers per hour. See, 50 kilometers per hour means here per hour indicate 1 hour. So this per hour is nothing but 1 hour. So a car is moving 50 kilometers. The distance covered is 50 kilometers per 1 hour. Per hour means 1 hour for it has covered 50 kilometers of distance. So that is the speed of the car. So what is the speed? This distance and time you can call it as the speed. The speed of the car is the 50 kilometers per hour. 1 hour for the car is able to cover the distance of 50 kilometers. Like that, we can explain that one. Okay. So here a car rarely moves with the speed of a car. Seldom it is given. See, seldom means here rarely. Okay, you underline that word and write the meaning of that one. So it is not familiar to you. So I am writing. See, a car seldom with a constant speed for 1 hour. See, rarely it moves with the same speed. See, 1 hour we told. Here 1 hour for 50 kilometers it is moving. We told. But all 1 hour it is not moving with the same speed, same constant speed it is not moving. Okay, see, starting once it has moved slowly. Then it will pick up the speed and moves faster. And when there is any other vehicle is coming, or it want to cross the road, or it want to take a turn, that time he makes it slowly. Okay, so then movement will be little slower. He reduces the speed. Then he turns, take a right or left or turning. Then after the 5 to 10 minutes, he will move again faster. Like that, some places he is making the vehicle to move faster. Some places the movement may be little bit, the fastness will be slowed down. Okay, this is indicates that all the places that a vehicle is not moving in a constant speed. Some irregularity is there. See, that's why we will take how can we calculate the exact speed? Means we will take it as the average speed. See, average speed of a car. Because we don't know. In half an hour, the same speed, the 10 minutes afterwards, same speed is there. We don't know. So we are having a target that it will cover the distance of 50 kilometers. In 1 hour, it will cover. Okay, after half an hour, maybe it is reduced. After 10 minutes, maybe speed is increased. We don't know. But it has reached, it is covered the distance of 50 kilometers. So we will consider the total distance covered. Okay, so the total distance covered by the moving body. So now we'll come to a conclusion. It is not moving constantly in all the distance. It may be irregularity in the speed. That's why we will calculate the average speed. So always average speed only we will consider. So average speed is equal to, what is the formula? See, speed means distance covered by time taken, we will write. So now it is average speed. So how to change that formula? We can call it as the average speed is equal to the total distance. So our target is total distance want to cover. So whether it is moving fastly, slowly, we cannot predict each and every time. Okay, so car has moved and covered the distance. So what time to what time it has taken to cover the distance, that we will see. See, total distance covered divided by total time. Total time taken. So in this way, we can go for finding the average speed of a particular vehicle. So the formula now it is changed because only the distance covered means we are not exactly telling that with the constant speed only it is moving. That's why the total average speed we will calculate. So in average means total distance covered by total time taken. Understand? So in that way we can calculate the average speed of a moving body or a vehicle car. Understand? So now we'll come to know this is the speed of the vehicle. See, we rarely find objects moving with a constant speed. So always we can see the vehicles. There are so many vehicles, car, bus, or a cycle, scooter, two-wheelers, many will be there. They are not moving with a constant speed. Okay, always there will be a irregularity in few stops or few traffic jam maybe. In that time they must be slowing, they will slow down the vehicle or sometimes they will be moving faster also. Okay, so no vehicle is moving constantly. That's why if the speed of the object moving in a straight line keeps changing, its motion is said to be non-uniform. See here two concepts they have given. One is non-uniform. Another one is uniform motion. So there are like this. If you consider the speed of a vehicle, we can divide that speed of a vehicle as it is under non-uniform motion or under uniform motion. Okay, so how to calculate it is under uniform motion? How to see? How to identify it is under uniform or non-uniform motion? You have to see the definition. See what is the definition is given if the speed of the object moving along a straight line. The object should be in a straight line. If the object who is moving, any object maybe. See, object is moving along the straight line and keeps changing its motion. It is said to be. It is keep changing the motion. See, the object is moving straight line only and it keeps changing its motion. How it is changing the motion? By changing the speed. Sometimes it is moving very slowly, sometimes normally, sometimes with the very fast speed. Like that, if it is changing the speed, changing the type of motion, it is changing there means it is coming under non-uniform motion. Understand? So then, an object moving along a straight line with constant speed. See, this is only same. It is moving in a straight line. Object is moving in a straight line with constant speed. Understand? So with the same speed only it is moving without any irregularity, without any stop or slow or fast, with the same speed only it is maintained and moved and covered the distance, then it comes under uniform motion. Uniform means almost equal speed. So total distance it is covered with the same speed only. Then it is coming under uniform motion. Understand? So in this way, by seeing the speed of a vehicle, we can calculate, we can come to know about the uniform and non-uniform motion. Okay. So if it is moving in a straight line, the body is moving in a straight line, whether it is a uniform or non-uniform motion, you can conclude that one, find out that one. Okay, now see, we can determine the speed of the given object once when we measure the time taken to cover the distance. So how we are determining the speed? By seeing the time only. So how much time it has taken to cover the distance, by seeing that only we are determining the speed. Now until here we calculated, we learned about the distance covered and about its speed. Okay, so now these two are related to one another. Time and distance are related to one another. So now we will study about this time, how the time has introduced to the earth. So how we are recognizing the time and distance together. Why this topic is together we want to read, that about we'll study here. So the new topic is the measurement of time. So there is a measurement of time. You already understood, to calculate the speed, time should be measured. So that about we'll see in a new topic, that is measurement of time. See, now already you understood why we want to measure the time. See, without the time, anywhere you are going or coming back, or when you get up early in the morning, first we will see the day has come. So what is the time? Like that. Before you could start from your house for any work, maybe you will see the timings on it. See, time is most important. Here, for this lesson, why we have to read the time means, see, distance covered means in what timing the distance is covered. That is most important here, because who is slower or who is faster, what is the speed of the vehicle, all this can be known only by the time. So we have to study, along with the motion of a body, we have to study the time also. How to measure the time? What are the units of time? Already you know time is measured with the help of a device called clock. Okay. So how the clock was introduced? About that we'll study here in the measuring of the time. So if we do not have a clock, what we can do? So nowadays we have different types of clocks. Okay, watches we have, clock we have. So if the device only not there, in olden days what they were doing? Okay, how they have calculated, they are calculating the time. How they will come to know, now it is afternoon, now it is evening. Okay, so this there is a little bit you think it over, and you find out what is the reason, maybe why they want to calculate the time. See, as we now have the device, we'll see and we'll set up the timings, and we'll start to move towards our work, or you are coming to the school, or breakfast time. This is all we will, there is a fix in your mind that now this may be the time, because every day you are watching the clock there, and you have decided proper work for different timings. So how the olden days people will be knowing about that? And there was no clock device also. There was no instrument called clock at that time. Okay, so what they will be doing? So for that, the answer is, in our olden days, our ancestors are there, no? So the father, grandfather, their fathers, there and all, that time there were no clocks at all. Our ancestors, they are used to see the environment. Our atmosphere only they are seeing and finding out the approximate timings. Okay. So that they are watching the environment, nature they are studying. To find out the timings, approximately they are measuring, and to find out the timings and particular work for this time only I have to do and finish. Like that they are approximately studying about the time. So what they are doing? See, they are observing the nature and they thought and they come to the conclusion that one thing, they have this changes in the observe. They are observing the changes in the nature and come to the conclusion that these changes are occurring in the nature according to definite interval of time. Okay, see, they are following changes they are observing in the nature, and these changes are occurring according to definite intervals of time. Got it? See, all the changes you observe in the nature after the definite period of time, certain duration of time, after that it will repeat again. Okay, so this makes them easy to find out little bit about the timings. Within that time, that duration, they have divided their work and start to calculate their work according to the particular period of time. Okay, so for example, here they are watching the environment or the nature I told. So what they are finding there? See, every day we are seeing that sun rises in the morning. Okay, and sets in the evening. Okay, so the sun rises every day in the morning. The time between one sunrise to next sunrise is, they are considered as a day. Okay, see, first sun rising. Okay, they are observing everyday nature, sun rising from one morning to next sunrise. They are considering it as a day. One day has completed. Okay, so this is the comparison. Means today the sun rises now. Okay, next day again the sun is rising. Okay, so that one sunrise to another sunrise part, they have calculated that the period of time as one day. Okay, so this is one day they have considered. Then again next similarly, a month was measured from one moon to the next, one new moon to the next one. Okay, so secondly they'll consider one new moon day. New moon day to next new moon day. That is, they are considering as 1 month. Okay, so this is the duration of the time for 1 month. One full moon day or new moon day they will take, and next new moon day they will be watching. So 1 month over. Like that, they have calculated little duration of time. So in that way, they are observing every month. Okay. So then later they come to the conclusion, a year was fixed as the time taken by Earth to complete one revolution. So when the year is fixed, the one revolution, one complete revolution of Earth, it is considered as 1 year. See, months they have calculated, day they have calculated, then 1 year also they have calculated. So in this way, the day, month and year will be calculated. So this is the duration of the time. In that way, they are measuring some of the details about the timings. So here The shortest one is 1 day far. Or half day also after the sunset, they can consider it as a half day. So within a half day, they cannot come to the conclusion that when is the, see, morning sun rises to until the sun comes to the straight on our head, it is coming means daytime in half is completed. Okay, 1 day in half day means that is when this light stops falling on the earth, that is the half day completed. Okay, like that they are deciding by seeing the nature, little bit of the part of the day or quarter part of the day they are deciding. By seeing the sun, they are finding out when now the sun raised means it is the morning, sun comes to our on the head means it is afternoon, sun come to the left part, that means the daytime has completed, light has finished, dark has started means the half of the day is closed. Okay, like that they are seeing the nature and comparing the timings. Maybe this is the half day, this is the quarter part of the day, this is the 3/4 of the day, like that they will be considering. So there is a risk in that after, see this, for a longer duration of the time they can decide. So now each and every hour they are not able to calculate. So later, after a few years later, so they have come to know about a concept that they made a clocks there. Okay, first they were introducing the pendulum clocks. See that pendulum, they are observing that pendulum clock. You can see your grandfather house means they have a pendulum clock. See that clock is the shape like this. Okay, so here one pendulum will be there. It is ringing after each hour. Here the hours will be made. Okay, like this, the hours will be there. Here the needles will be there like this. Got it? So each hour for it is ringing 1 time, 2 time, like that. So each hour for how many hours is crossing over, that many times it is beating. So like that pendulum clocks were introduced. Later on, the now advanced clocks are there with the which are using the cells. Okay, so watches we got that are later we have invented. So that clocks are invented. First the pendulum clock only invented. How it came to existence, that about we will study now. See, this pendulum clock is based on one concept, that is on the simple pendulum. Simple pendulum. Already I told you in the last class what is simple pendulum. It is nothing but just a ball or any heavy body is tied with a thread. That is what we'll consider as a simple pendulum. See, this whole clock designing, okay, the working of the clock, movement of the hands of the clock, all it is made by the use of the technique called simple pendulum. They observed the movement of the ball, this simple pendulum ball, then they find out a device called the watches or clocks, and like that the different types of clocks were introduced on the earth. So see this device, how it works, how it is related to the clock, that we will discuss now. See, the clocks will be like this, the different clock it is given here. See, first one is the wall clock, the pendulum clock in the olden days, like this it is. Then table clocks were there. Nowadays digital clocks we have. Okay, only by seeing the number here inside the cells will be fixed, with that it is able to rotate. So that rotation is also periodically. So each hour the same timings it will take, same period of time it will take. So that it is maintained with the help of the cells there. They are making it to move in particular duration of time. Then different types of clocks are made. So this idea has come to the earth because of the simple pendulum. So now let us see what is simple pendulum. Simple pendulum means just this is a ball for which we have tied a thread and any heavy object, a stone or ball like structure. Okay, that is what we consider a simple pendulum. So here it is fixed to the wall. Understand? See, a simple pendulum consists of small metallic ball. So this is a metallic ball. Okay. Then a piece of stone is suspended, or a piece of stone also you can take, which will be heavy, like that object, any object you can take and tie with the string or thread. This thread part, they are calling it as a string. Okay. With a rigid string, the metallic ball is called here as a bob. Here, this thread part, they are calling it as a string. Okay, they have given different name. So these are the parts of a simple pendulum. So we have given different name for this particular object part. See, this is only a thread. Okay, thread we will call. Here they are calling it as a string. Okay, a fixed string. Then here any heavy object, metallic ball or a stone also you can tie it. That part we are calling it here as bob. Okay, any heavy object you can take. So here metallic ball we have taken and that is named as bob here. Okay, it shows that simple pendulum. Now it is hanged here to a proper support. Here a nail is fixed to the wall or any wooden blanket part. Then it is hanged. Now it is in a constant position. Which position? It is in a constant position. This constant position part, we are calling it as mean position. The ball is not moving. Now it is just standing erect. It is not moving left and right. Okay, so it is in a constant position. That is mean position. Okay, so that position for O. This is named as O position. Okay, so next I want to draw the movement of that ball. So I will erase this part. See here one more diagram is given for that. See, this is the bob in a constant position, that is O position or mean position. It is fixed by a hook also. You can fix it to the hook also. If the string is tied to the hook, that hook is fixed to the ball. Like that it is handled. Because you cannot directly tie it over the ball. It may be slippery. It is fixed tightly there. So they have fixed the hook there, then it is fixed to the ball. Okay. Now, it is moving to the, if I drag this one, it is moving to the position A. Another position, if you leave that ball, another position B for it is coming. Okay, the picture shows the pendulum at a rest position means it is mean position. When the bob of the pendulum is released after the certain distance, it slightly moved to the towards A and I will leave the ball. So it will be moving from this position to this position. Again it is coming back to this position to A position. So this is what we will call it as one round. So that one round, this movement for we will call it as a to and fro movement. To and fro means from one way it is moving to this part and another way it is coming back from there to, that is fro movement. To and fro movement, it is coming back. So to and fro movement of this simple pendulum we are observing here. See, just you have to drag this ball like this and you leave. That time it will move to certain distance and come back to its position. So this is the movement of the simple position, simple pendulum. So from A we released. It is started to move from B, coming back to the A. So this is one complete rotation, one cyclic way it is moving. So this is what we will call it as a periodic motion, because it is following same duration of time to complete one complete rotation. So it is under periodic motion. See here, for the simple pendulum, if it is completed one complete round, we will consider it as one oscillation also. One oscillation means one complete rotation of the movement of the bob. So it is to and fro motion of the bob. One circle of the bob will consider as one oscillation. Okay, so the pendulum is said to have completed one oscillation when its bob move from O to B, B to A and A to O. This is one oscillation. Or you can start by leaving from A. So A to B and coming back to A is also considered as one oscillation. Okay. So this one oscillation, for how much time it has taken. Okay. So that we have to see now. Okay. See, the pendulum also complete one oscillation and then we have to observe the time. The time taken by the pendulum to complete one oscillation is called time period. See, this one oscillation, for how much time it has taken, that is, we call it as time period. Period means it is the time duration. How much is the time taken to complete one oscillation? That is, we will call it as time period. Okay. So this is the activity related to, there is an activity related to this. Did you understand this one? So this is the mean position where the constant is there, no? That is what we will call it as a mean position. And these A and B position we will call them as extreme positions. Okay, so mean and extreme positions you can calculate them. Okay, so this is A to B is the extreme position. It is the mean position. Now here one activity is given 13.2 activity. So for this, set up a simple pendulum as shown in the figure, and you have to see it is tied to a hard string, and with the help of the hook you can tie it and fix it thoroughly to the stand, wooden stand, for you fix it thoroughly so that it should be freely hanging from the stand. Okay, there is no disturbance in between in the movement of the bob. Okay, it is coming front of this stand with, and the movement of the bob should be freely rotating there. Like that you have to fix it. Then you should be careful that when you fix it, no, so below this you have to mark the O position, because if you hang it on the ball there back, you cannot write it. So we are writing O position in the down. Okay. So now you should not push the ball for its movement to observe. Okay. So just you drag the ball and leave it from A. So A to B it is going, B to A it is coming. We'll call it as one oscillation. Like that, you hold a stopwatch or clock which is having the seconds and minute needle. Okay, like that clock you hold or stopwatch is better to find the duration of this simple pendulum. See, you observe this movement is there, no? It is one rotation, how much it has taken. Now, second rotation also same timings it is taking. Okay, whether ball may be different or it may be heavy, it may be not heavy. So the movement you observe each and every time, it is taking the same duration of time. Same seconds it is covering to come back one to and fro motion part. Got it? So that you have to do and observe. So that this activity is given 13.2. So in that activity, you have to do the same thing. So just you drag the ball and leave it, you find out what is the time duration, time period it has taken to complete 20 oscillations for. Okay, so when you drag, no, this is the position A. So you last in the corner position A down, you can write it, and until where it is going, there it is, you can write it as position B. So A to B, you be observing each oscillation for it is very shorter duration of time it is taking. Okay, so here they have given the thread, how much length you have to take. So length of the string it is given 100 centimeter. For your activity for 100 centimeter length string you can take. Okay, so that is a fixed string length that it is given. With that you can drag and leave. That's all. So then 20 oscillations for how much time it has taken, that you have to record. So that activity you do 2-3 times again and again, you see the time duration it has taken, no, the same it will take. Okay, 20 oscillation for same duration it will take. So there is no much difference. Maybe 1 second or 1 or 2 seconds may be varying because you are dragging length maybe little bit more or less. So you do that activity 4 times or 5 times, then you see and record the timings also and record the number of oscillations. So number of oscillations, how much? 20 times. That is 20 we have fixed. Then time period, time how much it has taken here for the reference, they done that one, and time period it is 20 times we have done, and timings 42 taken for, time taken for 20 oscillation is 40 seconds it is given. 40 seconds, number of oscillations 20, timings 40 seconds, 42 seconds it has taken for 20 rounds. Okay, now you have to calculate the time period. Time period is equal to, what is that number of, what is the time taken? 42 seconds divided by number of oscillations. So if you cancel this one, if you divide and check, what is the timings? Okay, again you take the point 2 1 1. So see, if you divide, we are getting 22s of 40, again 2 is remaining. You don't have any number to take it down. So for the point, I am taking 1 0 here, 21s are 20. So you got 2.1 seconds. 0.1 second for one oscillation. So we have calculated, since one oscillation for, it is very less time. 2.1 second is very less time to calculate. So we have considered 20 oscillation for what is the time it has taken. That we done. That to 2-3 times or 3 to 5 times you do and check it. Then you find out the time period. So time period for, so what is the time, total time taken, that you should calculate. So 20 minutes, 40 minutes, 35 minutes, like that it may coming. Okay, seconds it is coming. Divided by 20 you do. Because 20 oscillation only we have calculated. So that's why divided by 20 you do. So you will get the time period of that particular simple pendulum. See here, one thing you want to remember, time period will be always the same until you take the same length of thread. It is fixed 100 centimeter here. Okay. So if you want to change the time period, means the length should be increased or decreased. then only the time period will be differing. Understand? So that's why the same length of the simple pendulum you have to take, and you do so many times also, the time period will be the same. So that you record in a table. Here they given the table also. So length of the time taken for 20 oscillations and time period, both you have to note down. 4 to 5 times you do and check it out. Okay, so this is the activity we done with the simple pendulum. So by using this technique only, they have made the first simple pendulum clock. Then later on, the new devices, the other types of quartz watches and all, they have invented. Understand? So in this way, time, duration of time, calculation of the time, we have completed. So then how it is applied to the this motion and time both together, how can we calculate, that we will study in the next topic. Okay, until that you be watching the classes and write down the points what I have given at the board. Thank you, Ananda.